In this presentation, we will learn how to delete the intermediate node of the circular singly linked list. So let's get started. Let us suppose we have the circular singly linked list and currently tail pointer is pointing to the last node of this list. Our target is to delete this particular node, that is node at position 3. For this purpose, there must be some post variable available with us which must contain value 3. Okay. This time we want to delete the node at position 3. Here we are not asking to delete the node after position 3. We are asking to delete the node at position 3. Okay. For this purpose, I'll keep a temp pointer which must point to the first node of this list initially, and then after this piece of code is required in order to traverse this list, so that this temp pointer must point to the second node of this list. I want to delete the node at position 3. For this purpose, this condition must be written over here, post greater than 2, because our temp pointer must point to the second node of the list and not the third node of the list. That's why this condition is required, post greater than 2. And here you can see inside this while loop we have temp equal to temp next and post minus minus. So it is clear that after the completion of this code, our temp pointer will point to this node, right? After this, I have declared a temp2 pointer, and this pointer must point to this node, that is the node to be deleted. That is why I am putting this line of code temp2 equal to temp next. Finally, we will update the next part of this node so that it can point to this node. We can do this by putting this line of code, and then we can free this node. And finally, we will update our temp2 so that it must store null instead of address 3000. You can see this is the resultant linked list, so obtained our intermediate node is now deleted. And the time complexity is obviously order of n because traversal is required in this case, right? Now let me just show the complete code in code blocks. So here is the complete code available. You can see struct node is declared over here. Then we have add to empty function, add at end function, create list function. Then we have this del inter function. In this function, we are passing tail pointer as well as pos, right? That is the variable pos. And here you can see that we are checking this condition. If tail is equal to null, then simply return tail. And then after that, temp pointer is declared, which must point to the first node of the list. And here we are checking this condition also. If tail next is equal to tail, that means if there is just one node in the list, then just free that node. Okay. After this, we will perform this procedure, that is while post greater than 2, temp equal to temp next, post minus minus. This whole procedure we have already seen, but here we are also handling this particular case if temp2 is equal to tail. That means if the node we want to delete is the last node of the list, then tail must be equal to temp in that particular case. Okay, tail pointer has to be updated so that it can point to the node just before the node we want to delete. Okay, that is why tail must be updated by temp. Then it is important to delete the node, and then temp2 must be updated by null. Then we can finally return tail back to the main function. Print function is similar to what we have seen already. And in the main function, tail pointer is declared, create list function is called. First list before deletion will be printed and then list after deletion will be printed. Here you can see over here that position is provided, that is 3. Although we can ask the user to enter the position, that is also possible. It's not a problem at all, right? Now let me just execute this code. Enter the number of nodes of the linked list, let's say 4. First element is 78, then 90, then 87, then 54. You can see over here that list before deletion is 78, 90, 87 and 54. After deletion, this is how it looks like, 78, 90 and 54. Okay, you can see that this node is now deleted. Now let me just execute this code once again. This time I will enter 3 elements. Okay. Let me just add first element 89, then 90, then 54. You can see over here the last node is now deleted, right? Here we have 89 and 90 only. And that's all what we need. Okay friends, this is it for now. Thank you for watching this presentation.